Okay, so getting into the content for 6-3 day 1, what we're doing today is really just looking at polynomial functions in general. So remember, poly means more than one, right? So we're talking multiple here. So these are things like x to the 6th or x to the 10th or however high you want, and what those functions are going to look like. Okay, so here are some key points right here. Is that all exponents have to be whole numbers in order to be a polynomial. All coefficients are real numbers, so you can't have any i's, which kind of makes sense, right? A sub n is the leading coefficient. So a sub n, notice how it's the very first thing that we have here. Okay, that is the leading coefficient. A sub 0, all the way at the end, is called the constant. Okay, and that's just when it's number only. Okay, that's your constant. If there isn't a term that is just a number and all of them have variables, then our constant is 0. N is the degree of the polynomial. So if you notice, the very first one, the highest degree, that is your degree of your polynomial then. Okay, so note that you do have to write it in descending order, right over here. Write it out in descending order of the exponents first. So your leading coefficient, again, leading, meaning in the front, right, would end up being 3 because all of these are in order. You have x to the 5th, x to the 3rd, x, and then no x, right? So it's in decreasing order, so 3 is our leading coefficient. The constant is typically your last one, but it's the one without an x or a variable, so it would be -5. And your degree is whatever your highest term is. It would be the first one, so that would also be 5. If you look at example 2, this one is not in descending order, so you need to write it that way first. So it would give me 5x to the 4th minus 4x to the 3rd plus 6x minus 2. Using that, our leading coefficient is 5. Our constant is -2. And our degree is 4. So let's talk about the types of polynomials. Okay, if your degree is 0, okay, that is called a constant. Okay, so that means that you would get something like f of x equals 4. Okay, that would mean you would have something graphed like this where x equals 4, and it's just a straight line. The next one is linear, and hopefully that makes sense to you. You see this all the time. It's something like f of x equals 2x plus 3. So you would have something like this. Very similar to the constant, but the constant is a horizontal line. Quadratic, hopefully these are familiar to you. Quadratic functions are what we just finished doing. So you could have something like -5x squared plus 8x minus 3, right? And we would have something along the lines of an upside down parabola. It really wouldn't look like that. It would be more like this, right? Crossing at -3, something along those lines. All right, now getting into ones that you haven't seen too much are cubic. So cubic functions are to the 3rd power. So something along the line of you could just do 2x to the 3rd. Okay, you don't have to have all these other ones. And that goes for all the ones up here too. Okay, this could just be 2x. This could just be something x squared. Or you could have everything but the last part. Okay, you don't have to have every single term. You could have something like this. I keep doing that. -x to the 3rd plus x. Okay, that's still a cubic because the very first one, your highest power is to the 3rd. Those graphs are going to look a little different. It's going to have just like a little curve in it. It's kind of like an Egyptian type dance, you know, like walk like the Egyptian, one's up, one's down type of thing. And then the last one is called quartic, okay? You need to know these, and hopefully that doesn't scare you too much because you already know this and this. Cube, right? If you have a perfect cube, you know is 3, right? So it would be to the third. Quartic is just like quadratic, so that's the fourth. The only thing to remember is constant, but we just talked about that up here, which is ones that don't have a variable. So quartic, again, that's the same type of thing. You could have something like negative 7x to the fourth plus x minus 5, right? And so you could have everything, but it could just be like that. This is very similar. It would be kind of like a quadratic, but then it would have like a little, almost like a W or an M. And sometimes it's different like this. Sometimes it's much smaller. Okay, it just depends on the graph. All right, so let's get into what these look like, okay? Yet again, we're just kind of powering through each one of these. So f of x equals 2, again, constant. We're looking at something that really is just like linear. If you're focusing on this one, it would look something like this, where it is decreasing. Remember, all the rules still apply. Quadratic, we would have something like this. Cubic, once again, kind of Egyptian-like. Quartic would be like a W. And then our last one, quintic. Okay, this one we haven't talked about just yet. You don't have to memorize that one. But it's just like the cubic, but it has like a little extra up and down. Okay. So we're going to determine whether the following functions are polynomials. If they are, write them in standard form, state its degree, type, and leading coefficient. If they're not polynomials, explain why. Okay, so let's get back to this. First, we need to determine whether it is or is not a polynomial. So looking at letter A, this one is a polynomial, right? Because we can go through our process that we were talking about up here. All exponents are whole numbers, coefficients are real numbers, and there's no x in the denominator, right? No x in the denominator, no x is power, so we're good. So this is, right? So we are going to write it in standard form. It is exactly how it is written. It's already in order. So we're going to say our degree. Our degree is 3 because that's the highest power. The type is cubic then. And the leading coefficient, I'm going to put LC, would then be 1 because there's nothing there. For letter B, don't get fooled because there's a fraction. Remember, you can have fractions. This is a polynomial as well. We do have to rearrange it a little bit to put it in standard form because the x to the fourth needs to come first. Because that needs to come first and it's our highest, that is our degree, which makes it a quartic. And our leading coefficient is then x. Now let's see what's different, and hopefully we recognize that. There is an x as an exponent, so it is not a polynomial. X is an exponent. Can't have that. And then our next one, okay, this is also not a polynomial. And I hope that we're seeing what's different about this one. You notice we have a -2 as an exponent. Like we talked about before, to get rid of a negative, we would throw that x in the denominator, and we cannot have x's in a denominator. Or just no negative exponents. Okay. So we're going to determine whether they're polynomials. If they are, write them in standard form. So we're doing the exact same thing, okay? I encourage you to do these on your own first and then watch me do it after. All right, so let's talk about direct substitution. We can do this the exact same way as what you're used to, or you could potentially do this through synthetic if you wanted to. So first one, we're trying to find f of positive 3. And if we're doing that, all we have to do is take a 3 and plug it in, right? So we replace x with 3. So we have 2 to the 4th minus 8 times 3 squared plus 5 times 3 minus 7. Now, be careful with these. You do not times 3 before you go to the 4th. Remember, order of operations, you have to do the exponent first. So make sure that you always do those before you start multiplying, okay? So the first one gives me 2 times 81 minus 8 times 9 plus 15 minus 7. So if I keep going, 81 times 2 is 162. This gives me 72, and then 15 and negative 7. If we then add from left to right, you would end up with 98. Now, yes, you could still do this with substitution. You would have 2, 0, negative 8, I'm sorry, synthetic division, 5 and then negative 7, and your answer would be here, which I bet you would get 98. So it'd be 2, 6, 6, 18, 10, 30, 35, 105, then 98. Okay, same answer. You just got to make sure you have your zeros. The problem is when you do direct substitution with something like this, all right? This you cannot do synthetic division. You have to plug it in if you have more than just a number like in the first. So because of that, we are still going to do the same thing. We have 5a minus 2, and that is replacing your x. So we have 5a minus 2 squared minus 5 times 5a minus 2 plus 8. Okay, now here's a big, big thing. Okay, on this part, you have to FOIL this. Okay, so you have to write it twice when it's talking about being squared. You cannot just distribute it in. Okay, and most of you are probably thinking, well, wait a second, we've been doing distributing it in all this time. Well, that was when we had something like 2x over y z squared, okay, and you're throwing in a 2, right? Notice how there's no adding or subtracting here, okay? So we can distribute it in. When there's adding or subtracting, like what we're doing, you have to FOIL. So we would end up with 25a squared, then minus 10a, which would give you negative 20a, and then positive 4. You would also need to distribute the negative 5, so you get negative 25a plus 10, and then still got plus 8. Our final answer for g of 5a minus 2 would be 25a squared. If you add the a's, you would get negative 45a. And then if you add everything else up, you end up with 22. Okay, notice how our final answer ends with f of 3 or g of 5a minus 2. You're not trying to get f by itself. You're solving for f of 3. So leave it that way. All right, go ahead and try 6 and 7 on your own. All right, so we have a couple left, and these are super important. I would make sure that you try them out on your own and see what happens. Okay, so we end up getting our first one, which was our first one, which was 8x squared minus 6. And then we are subtracting everything from my second one. And be careful here, you're subtracting all of it, not just 9x. So just like we always do, this is actually minus 9x squared minus 3x plus 3. So when we add everything together, we get negative x squared minus 9x plus